Welcome to This Explainer. Today, we're diving straight into the fascinating, mind-bending mechanics of large numbers. We all instinctively understand the small scales of daily life, buying groceries, measuring a room, but how on earth do we mathematically codify the truly massive? Let's figure it out.
Here's our quick roadmap for today. First up, we'll meet the giant numbers. Second, breaking down and building up. Third, the art of rounding off. Fourth, Indian versus international systems. And finally, number 5, the ancient Roman way.
All right, section 1, meet the giant numbers.
So we are seriously expanding our mathematical toolkit today, moving way beyond the thousands and pushing right into 7, 8, and 9-digit territory. Take a look at a massive 9-digit number like 15 million, 50,000, 2,000. When you're staring down that many zeros, it honestly feels kind of abstract, right? Like, what does a scale like that actually represent in reality? Well, it's definitely not just random data. That is the staggering 15 crore kilometer distance from our Earth to the Sun. To put that into perspective, without these massive digits, we literally wouldn't even have the language to describe our own solar system. It's an absolute necessity for astronomical realities.
But to make sense of these giants without totally drowning in a sea of zeros, we rely on something incredibly useful, a place value chart. Notice how it takes numbers and structures them into distinct periods, or families, the ones, thousands, lakhs, and crores. It essentially takes a chaotic, jumbled string of digits and turns it into a highly readable, organized map. Now, the absolute crucial takeaway here is understanding the difference between face value and place value. Face value, that's just the digit staring right back at you, like an 8, simple enough. But its true power, its place value, is entirely unlocked by its location on that chart. An 8 in the tens place is just 80, but move it over to the 10 crores place, boom, it explodes into 80, 100,000, thousand. When it comes to numbers, location literally dictates the whole shebang.
Moving right along to section 2, breaking down and building up. Okay, so now that we know exactly where these numbers live, how do we navigate, compare, and actually manipulate them? Well, by comparing digits from left to right, we can seamlessly organize massive sets of data. We can put them into ascending order, which is climbing from the smallest up to the greatest, or descending order, stepping down from the greatest to the smallest. And the trick here is super simple. You always start comparing at the highest place value, way over on the far left. You can also engineer entirely new values from random scrambled digits. Using descending order builds the absolute largest possible number, while ascending builds the smallest. But listen up, because there is a golden rule when you're building the smallest possible number. 0 can never, ever take the lead position. If you drop a 0 on the far left, it just vanishes, and suddenly your data size shrinks. So always place your smallest non-zero digit first, and then just slip that 0 right behind it into the second spot. All right, on to section 3, the art of rounding off. Sometimes exact, precise numbers are just total cognitive overload, and that is exactly where the vital survival skill of estimation comes in. Our source material uses a pretty brilliant scenario to demonstrate this, called the lion's dilemma. Imagine a hungry lion is standing right at position 38,245. There's prey located at the neighboring 10,000s, so one herd is at 38,000 and another herd is at 39,000. How does the lion use rounding to decide which prey to chase so it can conserve its energy? Well, if we plot this out on a number line, that animal instinct becomes completely obvious. The lion is at 38,245. The exact halfway point between his two options is 38,500. And because our lion hasn't reached that halfway mark yet, 38,000 is significantly closer. So it hunts there, saving vital energy. At the end of the day, rounding is simply about finding the most efficient, workable anchor point. And that raw animal instincts translates directly into 5 foolproof mechanical steps that you can use for any massive number. First, mark your places. Second, pinpoint the rounding digit. Third, look at its immediate right-handed neighbor. Fourth, if that neighbor is 5 or greater, you add 1 to your rounding digit. And fifth, if it's less than 5, you keep it exactly the same. After that, everything to the right just zeroes out. It's an elegant, highly logical system.
Let's turn to section 4, Indian versus international systems.
So, when we try communicating these massive scales globally, we run into a really interesting friction point. Not everyone groups data the exact same way. Imagine a conversation where one person argues a house costs 50 lakh rupees, but the other insists, no, it's 5 million. The big revelation here? They are both completely correct. It's the exact same underlying value, just translated through two entirely different cultural systems of numeration. Our source provides this excellent side-by-side table that acts like a perfect mathematical translator. The Indian system utilizes lakhs and crores right after the thousands. But on the flip side, the international system relies on the global language of millions, strictly grouping things by hundreds, 100,000s, millions, 10 millions, and so on. So how do you actually tell them apart at a quick glance? Well, the visual secret to instantly recognizing which system you're looking at lies entirely in where the commas are placed. In the international system, commas keep a very steady rhythm, every 3 digits, starting from the right. 3, 3, 3. But the Indian system kind of breaks that rhythm. After the first 3 digits, it places a comma every 2 digits. Those simple little commas are the crucial visual cues telling your brain exactly how to process the massive scale. And that brings us to Section 5, the ancient Roman way. Now, to truly appreciate how amazing our modern place value chart is, let's take a quick step back in time. Let's see how ancient civilizations managed long before that chart even existed. The Romans, they didn't use our handy 0 to 9 digits at all. Instead, they used just 7 specific letters as the building blocks for a completely different kind of mathematical logic puzzle. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. And because they completely lacked place values, meaning an X is worth 10 no matter where it happens to sit, they had to rely on really strict rules of positioning. For instance, a symbol can only repeat a maximum of 3 times. Also, smaller numerals following larger ones mean addition, so a V followed by an I is 6. But flip it, and a smaller numeral before a larger one means subtraction. Placing an I before a V means 5 minus 1, which gives you 4. Literally, it required active calculation just to read a standard document. As we wrap up this explainer, I want to leave you with this final, provocative thought to ponder. How did our incredible journey from calculating those ancient Roman letters to utilizing modern, comma-separated millions and crores completely unlock humanity's ability to measure the stars? Because at the end of the day, these aren't just digits on a page, they are the mathematical architectural tools that literally allow us to comprehend the universe. Thanks for joining me on this explainer. Keep questioning the systems around you, and I'll catch you next time.